Hi everyone, this is Kiranmai from H&S department. Today in this session, we are going to learn about optical fibers. Under this topic, we are going to discuss about introduction for optical fibers, principle of working, construction of an optical fiber, and working of an optical fiber. Coming to the optical fibers, before that, why optical fibers came into existence? What was the need of it? See, the light waves like lasers are used for the communication purpose. They want to communicate their messages through lasers. There are two reasons for it, because lasers is having very high frequency and they are more informative carrying capacity compared to conventional radio and microwaves. So light waves cannot travel as the light waves, whatever the light waves will take, they cannot travel for longer distances because their energy is dissipated very fastly. So they need one medium to travel from one place to another place, like a guiding channel for electrical current. So optical fibers provide such necessary waveguide for the light, like uh, like a cable for the carrying of electrical current. The same way, optical fibers also works like a cable to carry light radiations which are having messages through it. Fiber optics technology is increasingly replacing wire transmission lines in communication system and also electrical wiring even in our vehicles and houses. Then what was the basic principle that works to carry a signal from light signal from one point to another point? The basic principle for an optical fiber is total internal reflection. So what is total internal reflection? To have it, first we should have an idea what is reflection and what is refraction. See, when a light ray traveling from one medium to another medium strikes a object between it, interface between it. There are two different scenarios which may happen. One is reflection, another one is refraction. Reflection means the incident ray will get back into the same medium. Whereas refraction means the incident ray will get into the other medium by bending. So these are the two things which can happen when a light ray travels from one medium to another medium. Uh, so bending of light ray in refraction depends on the medium it is traveling from. Either it is traveling from rarer to denser medium or denser to rarer medium. A medium with lower refractive index is called as rarer medium, and a medium with higher refractive index is called as denser medium. So when a light ray, if it is traveling from rarer to denser medium, the ray will get refracted towards the normal, whereas if the same light ray, if it is traveling from denser to rarer medium, the refracted ray will bend away from the normal, which you can see on the screen. See here, the ray is traveling from, in the first case, the ray is traveling from rarer to denser medium. So the ray is, instead of traveling in straight line, in the second medium, it is bended towards the normal. Whereas in the second scenario, where the ray is traveling from denser to rarer medium, it is bended away from the normal. So these are the two scenarios where the refraction is happening depending upon the medium of travel. So if the same case where the ray is traveling from denser to rarer medium, let the angle of incidence is increasing. What happens if the angle of incidence is increasing? Angle of refraction also increases, which means that the refracted ray bends more away from the normal. So in the same case, if you are go on increasing the angle of incidence for a particular angle of incidence, what happens? The refracted ray will trace the line between the two mediums by making refracting angle to be 90 degrees. Such angle of incidence is called as critical angle. The angle of incidence for which the refracted ray traces the interface between the two mediums. Such angle of incidence is called as critical angle. Now, if you go beyond this critical angle, what happens? The ray will come into the same medium. Such phenomena we can call it as total internal reflection. But this to happen, there should be two conditions. One, the ray should travel from denser to rarer medium. Another, the angle of incidence should be greater than critical angle. If these two conditions are satisfied, na, the ray will get back into the same medium. So this is the basic principle on what an optical fiber will utilized for the carrying of signal from one point to another point. So for the construction of a optical fiber, as we had discussed in the earlier slide, total internal reflection is the basic principle. So you should need two mediums. One should be of denser, another should be of rarer medium. That means one medium should have a greater refractive index, another medium should have a lesser refractive index. And the angle of incidence at the interface should be greater than critical angle. Uh, so depending upon all these conditions, for the construction of an optical fiber, they had chosen two materials called as core and cladding, where core will act like a denser medium and cladding will act like an rarer medium. And for the protection purpose, this core and cladding is covered with number of layers of outer jacket. It may be from 2 to 6 layers will be there. So the optical fiber is a cylindrical shape consisting of three sections. One is core, around it cladding, around it outer jacket. And the fiber core is surrounded with a cladding with a refractive index slightly less than that of the core. And to give protection to the fiber, an outer jacket is used. So for the working purpose, as I told you, total internal reflection is the basic principle. So the refractive index of core should be greater than the refractive index of cladding, so that the ray will travel from denser to rarer medium. Another thing, at the interface, the angle of incidence should be greater than critical angle, so that the ray will get back into same medium. By considering these two conditions, if a optical fiber is constructed, then when light is launched inside the core through its one of the end, it propagates to the other end due to total internal reflection and at the core cladding interface. So in the figure, you can observe that the incident ray, once it enters the core material, that is denser medium, at the interface between core to cladding, if the angle of incidence is greater than critical angle, the ray will get back into core medium. Again, at every point of contact at the interface, if you make angle of incidence greater than critical angle, the ray will get back into the medium, get back into the core medium itself, so that it can travel inside the core material and it reaches the other end of the material. So depending upon this phenomena of total internal reflection, any light signal can be carried easily from one point to the other point without any major losses in the signal. Because of total internal reflection, most of the signal will get back into the same medium and it travel very safely from one point to another point by reducing the losses of signals also. That's why in today's life, most of the cable networks, LAN networks, all are getting replaced with the conventional cables by an optical fiber cables, because of the advantage that the loss of signal is very less in optical fiber cable comparable to a conventional cables what we used in the previous days. Thank you.